Hello everyone, welcome to this webinar on improving database scalability and availability with Amazon RDS Proxy. Many applications, including modern-day serverless architectures, allows application to scale seamlessly, and it opens and closes large number of connections to the backend database and exhausting its resources. And an application has a requirement of high availability to handle the transient database failures and, more importantly, better security. In this session, I'm going to talk about how Amazon RDS Proxy helps scale and increase availability of your application without impacting the database performance. My name is Surender Munimohan. I'm a Senior Database Specialist Solutions Architect, and I help customers to build scalable and efficient architecture with the purpose-built data stores with AWS. Here's an agenda for today's session. First, we'll start by briefly discussing the fundamentals of Amazon RDS service. Then, we'll discuss about the motivations that went into building RDS Proxy. Next, we'll discuss about the three key benefits of RDS Proxy on how it helps your application scale better, make it highly available, and more secure. I'll show you a demo on how RDS Proxy helps scale your application with the minimal impact to the database and how it increases your application availability to the database failures. We'll finish off with some of the best practices that we learned from our customers when using RDS Proxy. We have a lot to cover in this session. Without further ado, let's dive in. Amazon RDS is a managed relational database as a service with a choice of popular relational database engines, both on open source and commercial. RDS is one of the AWS services that we launched way back in 2009, and we have a decade of experience operating and scaling database workload for customers in the cloud. Some of the benefits of running relational database in RDS is it removes a significant effort of managing and scaling the database and allowing you to focus on making your customers successful. We do that by making database easy to administer and performant and scale and highly available and durable, and more importantly, secure and compliant. Let's discuss about the motivation that went into building RDS Proxy. Modern day application move towards microservices and the serverless architectures. This allows application to scale without any issues. For example, AWS Lambda functions can scale up to 100,000 invocations very easily. But think about all these Lambda functions making hundreds of connections to the backend database, or even thousands of connections to the backend database. Then your DB instance will be using most of its resources in managing these connections instead of processing the queries. And this will decrease the database performance and affect your application. And all the applications currently want to have high availability and ability to handle the transient database failures. And these transient failures are common in cloud environments. And these failures are greatly minimized in RDS and Aurora. And it automatically detects the transient failures and performs the failover without any manual interventions. Even though the failover time is very fast in Aurora, most of the applications has a requirement to handle the failures with less or no interruption at all. And an application has a requirement of having more security control so that they can maintain a better security access to the database. Prior to launching RDS Proxy, what are the customer choices? To handle the high number of application connections, customers would typically over-provision the DB instance so that it has enough compute and memory resource to handle the surge of database connections. In addition to that, you also need to maintain a complex failure handling mechanism in your application code to overcome the transient failures during the failover events. The other option is to self-manage the database proxy solutions in a service like EC2. Running a self-managed proxy solution comes at a cost of deploying it and maintaining it. It comes yet another component in your application architecture that you have to take care of. And also, it's an entry point to your database, so you need to make sure it is highly available and can able to handle the failures. Based on the previous feedback from customers, They wanted a fully managed proxy solution. RDS Proxy is a fully managed, highly available database proxy that makes your application more scalable, more resilient to the database failures, and more importantly, it is more secure. Let's discuss about the RDS Proxy features and the benefits briefly here. As with most of the AWS services, RDS Proxy is a fully managed service, which means you don't need to deploy and maintain it. We take care of maintenance like a patching, upgrade, and setting up for high availability. It is fully compatible with MySQL and Postgres, which means if you're using MySQL or Postgres in your database, you just need to change the database endpoint to the RDS proxy in your application, and you're good to go. And what are the other benefits of RDS proxy? RDS proxy performs connection pooling with a multiplexing. It means whenever the database connections is not actively executing, we switch it to another client connections and do the work. So this helps to minimize the amount of connections that you open to the backend database, which in turn reduces the CPU and memory consumption of your database. The second key feature is fast and seamless failover. As you might know, failover in Aurora is very fast. It typically takes less than 30 seconds. And during this process, all the application connections get dropped because DB instance will go through the reboot. So the application will have to reestablish the connection to the backend database again. But when connecting to RDS proxy will preserve non-active connections as the failover happening there, and it will direct the connection to the newly promoted instance when it becomes available. And RDS proxy aware of the underlying instance, so it is very fast in directing these role changes, and it's not relying on DNS. So you don't need to worry about DNS caching or downstream TTL delays. Because of that, it is able to provide up to 66% faster failover. The third key feature is security. RDS Proxy integrates with AWS Secrets Manager. AWS Secrets Manager is an encrypted secret store, so you don't need to store any credentials in RDS Proxy. On top of that, RDS Proxy allows you to enforce the IAM authentication. This IAM authentication is supported both for RDS and Aurora. With this, you can enforce all users who are connected to RDS Proxy must use an IAM authentication, and avoid hard-coding database credentials in your application code. We'll discuss little more details about each features in the coming slides. Before that, I want to briefly discuss about how RDS proxy works at a very high level. On the left-hand side, you have your application. It can be running in a PHP, Ruby, or a .NET, or running in serverless applications like running in AWS Lambda or containers. Any of these applications can connect to RDS proxy. On the right-hand side, you have your database. It can be running in Amazon RDS and Aurora. RDS proxy sits in between your application and a database layer. Your application connects to RDS proxy, and it provides connection pooling, seamless failover, and better security controls like enforcing IAM authentication, and also integrating with AWS Secrets Manager. And the RDS proxy will connect to the backend database. It can be running on RDS, or it can be running on Aurora. And RDS proxy is just not a single instance. It is actually highly available multi-instance proxy, which spread across multiple availability zones to give you a high availability and the scale that you would expect from a serverless services. Let's dive a bit deeper into how RDS proxy helps your application scale better. RDS proxy performs connection pooling, which minimizes the number of connections that you open to the backend database. For example, MySQL uses one thread per connections. When you open 100 connections directly to the MySQL instance, it creates like 100 threads. When an applications open and close a large number of connections at a very high rate, a lot of database resources will be spent on managing these connections instead of processing the queries. And it degrades the database performance. And if proxy performs connection multiplexing, it reuses the same database connection to serve multiple requests. For example, whenever the connection is not actively executing, during these times, connections switch to another connection to perform an operation. The connection multiplexing would work both for read-write endpoint as well as read-only endpoints. With this, you can increase the scalability of your application without overloading the database resources. And connection pooling would work both for read-write endpoint as well as for read-only endpoints for an Aurora cluster. As you know, in Aurora, you can have up to 15 reader nodes. When connecting to the RDS proxy read-only endpoint, it automatically performs a load balancing between the reader nodes. And during any role changes, RDS proxy will check the replication lag of the old and new reader instance and route the connection so that your application never sees the stale data. Let's discuss about how RDS proxy improves your application's availability. This is a simple example to showcase how RDS proxy improves application availability. Let's say you have an application connecting to the backend database. It may be either running an RDS and Aurora through RDS proxy. In this case, it has one primary instance, which is represented in red, and one standby instance, which is represented in blue. When there is a database failover, RDS proxy will preserve the connections which are not active, and it will continue to accept the connections from an application even during the database failover process, and it will continue to queue up those connections. As soon as the new instance comes up, it will connect to the promoted instance and pause on any pending transaction that were queued up in RDS proxy. Now, if you're connecting directly to an Aurora cluster endpoint, maybe the overall failover can take less than 30 seconds. In that 30 seconds, most of the time goes into DNS propagation. On top of that, if you have downstream TTL or if you have an application side connection pool with the long living connections, your failover may experience or the failover time even become longer. With RDS proxy directly connect to an Aurora instance, it's fully aware of the cluster topology. So whenever there's a change, it'll quickly detect the change. Because of that, it provides up to 66% faster failovers. I want to show you about the test that we performed. In this test, we used a client to directly connect to a DB instance. And we did another test, the client to connect to the RDS proxy. And we performed it about like around 100 iterations. We measured how long it will take for the client to reconnect and execute a transaction after the failover. The orange line shows the direct connection to the database and the failover time as a result of that. We use MariaDB Aurora driver, which is already optimized to reduce the failover time. With that, we notice the time it takes for the client to connect and execute the transaction took anywhere between 10 to 30 seconds after the failover. The blue line shows the client connecting to RDS proxy. As you can see, the time it takes for a client to reconnect and execute a transaction after the failover took anywhere less than 3 seconds. As you can see, the RDS proxy is able to provide faster failover even when you compare with the already optimized MariaDB Aurora driver. Let's dive a bit deeper into RDS proxy security aspects. First, I want to talk to you about how you can authorize and authenticate with RDS proxy. You can continue to connect to RDS proxy using the native way, that is, you establish a connection with your MySQL or Postgres database using the same old username and password. And the next option is you can store the secrets in the AWS Secrets Manager. As I mentioned, Secrets Manager is an encrypted secret store. You can store the database secrets. With the Secrets Manager, you can easily rotate, manage, and retrieve the database credentials. You can just make an API call from your application to retrieve the secrets and just start the connection. Another added layer of security control is that you can use the IAM authentication with an RDS proxy for authentication. It is much more secure than connecting with a username and password. Once you get authenticated with RDS proxy with any of the above method that I mentioned, then RDS proxy will get the credentials from the secrets manager and connect to the database. I want to briefly explain about how IAM authentication works. First, your application gets the authentication token from an IAM. And using that token, your application make a connection to an RDS proxy. Once that is validated in RDS Proxy, as mentioned previously, RDS Proxy will retrieve the secrets from the secrets manager and it connects to the database. By using this technique, you can enforce a strong IAM authentication requirements for your database. Now you know how IAM authentication work. Let me show you how you can able to use it in your code. It is a simple code snippet written in Python. It is very much the same for other languages as well. The first highlighted line shows how to generate an IAM authentication token. And the next line shows how you can able to use the token as a password. And these authentication tokens are generated using AWS Signature for version, and it has a lifetime of only 15 minutes. So this is a very simple and a secure way to connect to your database without storing the passwords in your code. Now, I just want to show you where you can enforce an IAM authentication in the RDS proxy console. As you can see, there's an IAM authentication in the connectivity sections when you create the proxy, where you can able to set an IAM authentication to required. It is a very simple and straightforward. I just want to show it to you. Next thing I want to discuss about the new feature that we recently introduced in RDS Proxy. Typically, customers run their app servers and database servers in one VPC, but it can be running on different subnets. Given that both app servers and database servers running in one VPC, it is very easy to provide an access between each other by just allowing the security groups or the subnet IP range. Let's say you have some reporting application running in a different VPC in a same account, and that application wants to access the database, which is running in a different VPC. Usually you have an option to do a VPC peering. Basically, you have like two VPCs and those are paired to each other, which means it can communicate with the private VPC. But when using VPC peering, basically you're opening up two VPCs to each other, even though you just want to access the database which is running in another VPC. With an RDS proxy cross-VPC connectivity, you can just enable the cross-VPC connectivity by creating an endpoint in your RDS proxy. Using this endpoint, your application in another VPC can communicate to the RDS proxy, which is running on a different VPC. Next, let's jump into the demo.
In this demo, I will show you how RDS Proxy helps scale your application with a minimal impact to the database. This is an architecture I'm using in this demo. I'm going to fire up tons of Lambda functions using an artillery load generation tool from this EC2 instance and monitor how RDS Proxy handles a load with a less impact to the database. I already provisioned these resources running in the same VPC, and the security groups are configured to allow access. Let's look at these resources in the AWS Management Console. Let's first check the EC2 instance. So this is the EC2 instance which I'm using for this demo, which is running on Amazon Linux. This is where I installed the artillery load generation tool. Next, let's check the Lambda function that I'm using for this demo. This is a Lambda function which I'm using for this demo, which is running on Python 3.7. And this is the function code for this Lambda function. This function basically connects to a proxy, and then it just runs a simple select query. And I put it in a loop so each Lambda invocation can trigger 10 connections to the proxy. And also I configure the end variables in the configuration sections for the DB endpoint, DB name, user, and password. Next, let me quickly walk you through the RDS proxy. Already provisioned this RDS proxy to save some time. This proxy is compatible with the MySQL engine. I'm using Aurora MySQL for this demo. So let's check the configuration for this RDS proxy. So this is the proxy identifier, and this is the IAM role that this proxy is using to access the secrets manager. You can create this IAM role, or you can able to just RDS proxy to create it for you when you're creating this RDS proxy. And this is my security group, which I'm using this for proxy, where I allowed access for the Lambda to access this proxy. And I set up, and also you have an option to set up TSL encryption, but I'm not using this for this demo. And also I set up a ideal client connection timeout, set it to 3 minutes. And also you have an option to enable the logging for the RDS proxy. For example, if you want to do troubleshoot and you want to understand the behavior of RDS proxy, you can enable this enhanced logging so that it will log all the client connections, so you can able to review it for future use or if you're using for any troubleshooting. Next, let's check the RDS proxy endpoints. These proxy endpoints are similar to RDS or Aurora proxy endpoints. If you're already familiar with it, this is very much the same. Proxy allows two endpoints. One is a read-write endpoint and next is a read-only endpoint. You can create the read-only endpoint if you're using Aurora as your backend database, and you can use this endpoint to serve the read-only traffic for your application. In this demo, I'm using just a read-write endpoint. Next is the target group. The target group, this is where you associate your DB instance. Either it may be Aurora or RDS instance that RDS proxy can connect to. Here you can able to specify certain parameters on how RDS proxy should behave when connecting to the database. Let's look into this default target group that I created. So here you can able to specify certain parameters. As I mentioned, this is the connection pool maximum connections. Basically here I configured 90% of the max connections for the connection pool. You can configure this based on your application needs. You can split it into 90-10 or 80-20, whichever your application needs are. And next is the connection borrow timeout. Connection borrow timeout is nothing but here how long the proxy has to wait for the database connections to become available before returning a timeout error to the application. So it's wait for 2 minutes. If the 2 minutes, if it doesn't have any connections, then it'll send a timeout error to your backend applications. The other options we have is session pinning filters. If you notice like a lot of pinnings happening on your RDS proxy, then you know it's safe to not to pin some of these transactions. Then you can select this and exclude the variable sets in here so that RDS proxy won't pin those connections. And also we have an initialization query. So if you're using set statements to perform identical initialization for each client connection, you can move those statements to the initialization query to take a benefits of connection multiplexing. And next, this is a database that I associated with this proxy, which is basically our Aurora MySQL instance. Now let's check the Aurora MySQL instance that's associated with this proxy. Right, so this is the Aurora instance that I'm using for this demo. This is basically running on Aurora MySQL cluster. And it has one writer and one reader, which is running on R5 Xlog instance type. I also configured the metrics that on the CloudWatch dashboard that we will be viewing when I start the load generation tool. This has two metrics, basically like one is for the client connection setup, so the number of client connections connecting to the RDS proxy, and next one I set up is the database connections, then how many number of database connections that proxy making to the database. Okay, now we reviewed all the resources which is in the console. Let's fire up the artillery tool to generate some load. Let me open up the terminal. Okay, I already SSH'd into my EC2 instance. I wrote a small YAML script to generate the load scenarios for the 5-minute duration. Let me start the script. You can see the artillery started firing up more Lambda functions. Currently it's launched 2k Lambda functions and it's continued to going to increase throughout the 5-minute periods. Let's go back to the dashboard and monitor the metrics. Let me also enable the auto refresh so that we can able to see as the metrics get populated. CloudWatch publishes the metrics for every minute, so we'll wait for the metrics to come in. I already see there's a one data point came in, which is the client connection, which is around 250, and I can see the second data point came in, which is around 16k. The database connection is currently around 85, and this is going to increase throughout the next 5-minute period, and it's going to fire up more Lambda functions, and we're going to see how the database connections get handled. We can see that their data point came in. So currently the client connection around 15K and the database connections around 400. Artillery continued to generate more load and is almost reached its peak now. As you can see, RDS Proxy is handling more than 20 times the database connections. This shows how RDS Proxy helps scale your application with a minimal impact to your database. Let's move on to the next demo now. Next demo, what I want to show you is how RDS Proxy increases the application availability. I've written a small Python script which connect to Aurora cluster endpoint and report the time and the instance name of the current writer. Then we initiate a failover and observe how long it's going to take to perform a failover. In the next test, we are going to connect to the RDS proxy endpoint and observe how long it's going to take to perform a failover when connected to RDS proxy. Now let's jump back into the terminal and run the script. Okay, now I already SSH into my terminal. Let me copy the command and run it. Here I'm connecting to a Aurora proxy-demo.cluster. Okay, let's start the script. Basically, it's reporting the time and it's connected to the instance name of the current writer and the version. Okay, while the script is running, let's hop into the RDS console and trigger the failover. Okay, this is the Aurora cluster. Let's select the instance and actions and perform a failover. Let's hit failover. Okay, now it's going to start the failover process. Let's hop back into the terminal and check the behavior. The script is still running. Let's give a moment. Okay, there you go. So as you can see, first, whenever we initiate a failover, Aurora will perform a reboot and then it connect to the new writer. Here, during the reboot, we are not able to connect to the current instance. And then we can see something else here as well. Basically, whenever we perform a failover, we change the DNS endpoint of the current writer. So we are saying it's still connecting to the old instance, so that's why it's showing DNS is stale. And then it connects to the correct instance here. Okay, let's stop the script. Let's examine this a bit closer. All right. At 23:11:50, it performed a reboot. So that's why we're noticing it can't connect to the instance. So it took just 2 seconds. And then it performed a failover, but the script was still connecting to the old instance, which is Aurora-proxy-demo1 instance, US West 2B, which is a current reader. Since it's pointing to the old instance, which is a reader instance, that's why it's showing us DNS is stale. So DNS stale is almost took like from 52 to 12:05. 13 seconds, the DNS was stale, and then we got a message like saying the failover is completed. So overall, the process, including the restart and the DNS stale, it took about 16 seconds, which is pretty fast overall when you think about it. Now let's connect directly to the RDS proxy endpoints and monitor the behavior. Okay, let me clear the screen. Let me copy and paste the proxy endpoint command. Okay, so here is the RDS proxy endpoints. That's RDS proxy demo.proxy. So this is a proxy endpoint. Okay, let's start the script. Okay, this is a new instance it's connected to. I'm reporting the new instance name, Aurora-proxy-demo1 instance. Now let's jump back to the RDS console and initiate a failover again. Okay, let's do a quick refresh to make sure we're seeing the current writer instance. Okay, now demo1 dash instance is a new writer. Let's perform a failover. Okay, while the failover is happening, let's hop back into the terminal and monitor it. Okay, just going to take a moment to perform a failover and see if you notice any difference when connected to RDS Proxy. Still going fine. Did you see that? It automatically changed from demo-instance1 to demo-instance1 US West 2B without any error or without any DNS stale issues. Let's stop the script and examine a bit closer. All right, at 23:15:15, it was still connecting to demo-instance1, and there's like a 1 second delay where during that 1 second where it performed a failover, and as soon as the failover was completed, it was able to connect to the new instance because RDS Proxy, already aware of the cluster topology, whenever there's a new change detected, it automatically holds the connections and point to the new instance. So that's the reason we did not see any errors, and it automatically point to the new writer instance. This is what I want to show in the demo on how RDS Proxy increase application availability.
I wanted to share some of the best practices that we learned from working with other customers. Applications don't continuously use the connections. If you open a connection and you perform a transaction, I'm done with it. And this connection will be used for another connection, so on and so forth. RDS Proxy performs the transaction level sharing and load balancing that improves the scalability. Because of that, your CPU and memory resources are used to process these queries instead of just managing these connections. And there are certain situations where multiplexing may not work in RDS Proxy. For example, when you change the session variable or some configuration parameter at the session level, RDS Proxy will pin the connection and stop sharing these connections. Basically, if you're allowed to do that, then we'll be leaking the session state. So basically, we don't want to do that. To safeguard that, RDS Proxy does the connection pinning. In this state, the connection will not multiplex. I want to discuss about on what are the situations the connection get pinned. It can happen for the following reasons. Let's say when you're setting any variables using the set commands, or doing any explicit lock, like using a lock table, or when creating a temporary tables, or when using the prepared statements, or if you run like a large query which is greater than 16 KB, during these statements, your connection get pinned. And connection pinning won't affect the character set changes or a collation or a time zone or auto commit setting. So you don't need to worry about the connection pinning for these. And also, calling the stored procedures or stored functions does not cause the pinning. RDS Proxy does not detect any session state changes resulting from such calls. So you make sure your application does not change the session state inside the stored routines. And RDS Proxy will reuse the pinned connections after the client goes away. So basically, if your client for disconnected for whatever reason from RDS Proxy will reuse the client connections. And also during the database failures, the pinned connection will get closed because database will go through the reboot process. Basically, your clients need to reconnect and set the session state again if that connections are pinned. I want to quickly show you how can you avoid pinning. RDS Proxy allows a couple of things that you can able to do to avoid the pinning connections. One is that if you don't care about the variables that being shared between these sessions, you can exclude those variable sets in the session pinning filters and just enable the exclude variable sets in the drop-down box. And the next one is an initialization query. Here, you can set the variables or statements to make sure that each connections has an identical settings, such as a time zone or a character set. So the proxy can execute a query for each database connections. This way, you have a consistent session state without resulting in a connection pinning. One thing to note here is initialization query is currently not supported for Postgres. It is only supported for MySQL. And what about monitoring? RDS Proxy published a lot of metrics for you to review and understand the proxy usage. I have highlighted the few metrics that you need to keep an eye on. First is database connections. This metrics will provide you information about the number of database connections that your proxy is making to the database. And the next is database connections currently borrowed. If you have a database connections and the database connection currently borrowed is the same, which means that you're running out of capacity in terms of connections, then you would want to watch the borrow latency as well. This will tell you if there is too many client connections are waiting for the connection to become available. If that's the case, basically you just need to increase the DB instance class to get the more connections. And another thing that you need to watch out for DB connection currently session pinned. If you're noticing like a lot of pinning happening in the proxy, basically you need to review those and understand where the pinning is happening and see if you can able to minimize that. And another metric that you want to look out for is query database response latency. Basically, this tells the time it takes for the database to respond to database queries. If you're experiencing any latency in your application, it is worth checking this metrics to understand whether what is the database response latency is. With that, we came to the end of the session. To give you a summary of this session, we discussed about the RDS proxy and how it helps scale your application and increase the availability and make it more secure. And in the demo, I showed you how RDS proxy can handle influx of client connections by keeping the very minimal database connections. And in the second demo, I showed you how RDS proxy helps your application to be highly available during the transient database failures. And we finished up with some of the best practices. Thank you very much for attending this session. It was a pleasure spending time with you. And please let me know if you have any questions. I'm happy to answer. Thank you.